Hi everyone, in this video I would like to talk about transistors, specifically using them as small signal amplifiers. Transistors are a very phenomenal invention that have had a profound effect on the electronic industry. Its main uses are as switching devices so that it can store information as one or zeros, or that of small signal amplifiers. The need is basically because we have lots of our electronic circuits oftentimes are connected to instruments such as a microphone or sensors, but the information we get is very tiny, very small, and we would like to amplify it. So without further ado, this is the symbol of a transistor. This is the collector terminal where the current flows in, this is the base terminal, and this is the emitter terminal. But if you look it through a microscope, this is more what it would look like. Okay, so this is the emitter side, which has a lot of negatives. This is our base side, which has lots of positives, but it's much smaller than the emitter side. And then we have the collector, which is big and has a lot of negative charges. So essentially what we try to do is connect this to the base, to like a positive power source, and do the same with the emitter. We connect to, say, a ground or maybe a negative, and the collector side we connected to a positive source. So what happens is negative current basically flows from the emitter, and basically it starts overloading in this area. Lots of negative charge comes, so it starts moving forward because negative charges repel, and it attracts with this positive charge, but there are not enough positive charges, which is why we have this positive power source connected to it. So the current basically starts moving in this direction. Okay, then but at the same time we have a positive source connected here to the collector side, so current also flows from this negative side over here, attracts with a positive, and then it also starts moving forward, and over here these negative charges overload. So these negative charges start moving more towards the what's it called, this positive charge source. So that's basically how the transistor works. Now we're going to look at it using this pi hybrid model. Our previous diagram does not have it's not very good for circuit analysis, which is why we use this pi hybrid model. So we have this over here, we have our base, we have our emitter, we have our collector. We basically, this is our input source. This is basically whatever input source we have, like a microphone or a thermal sensor or a ultrasonic sensor. Current flows from here. Okay, it goes through this resistor. There's a voltage drop, and we call this V pi. This voltage drop is called V pi, and it flows over here to the emitter. At the same time, there's the emitter is not always connected to ground, just so you know. It can sometimes have like a resistor over here. Okay, and we also have this GMV pi. This is a current source, and this current source is basically our output source. And what happens is this output current source is going to go through this resistor. We connect this output resistor, and basically the voltage drop across this resistor is going to be our output V out. Okay, so and this is basically what we measure. Now I will show you the true magic of transistors or small signal amplifiers. So we have an input, we apply an input voltage between the base and the emitter. So basically, if provided we have a sufficiently high input, we can basically magnify it by connecting another power source to it. If we have sufficiently high, basically small changes in voltage leads to drastic changes in current, which is very useful for us. However, we do not want to keep on increasing it, because while on this model, this exponential model, increasing voltage basically increases the current, the output current, it has some negative effects. For instance, if you go back to this video, over here, we usually have a power source connected, and if we have a huge voltage drop, what this will do is draw a lot of power from this voltage source, which is basically reduces whatever battery life we have very fastly.